taxes. When taxes are higher, disposable income is lower. Consumption would be lower. Planned expenditure would be lower. So, but look at that. When demand goes down, so all of a sudden you are facing with what? Excess supply of goods. Excess supply of goods. Okay? Okay. Where does excess supply of goods go? Inventories. Inventories rise, but inventory space is limited, all right? So firms have to cut back their output. Cut back their output. Yes, everyone? Is okay? Let's go again.
So the income is from the fire workers?
Because of?
The fire workers?
No. That is your third approach to fund GDP. So this is GDP from output side. This is GDP from income side. Okay. So that planned expenditure is GDP from what? Expenditure side. Okay, these three are in equilibrium, equal in equilibrium. Okay, so yeah, I mean, you can imagine employment goes down because you were we talked. Did we talk about Ocon's law? In Ocon's law, Chapter 7, basically output and unemployment working opposite of each other. Okay. Yeah, we will talk about that later. So, unemployment. Okay. The plan was what? Doing everything in three ways. Intuition, graph, and algebra. Okay, let's do a little bit of algebra. So here we talked about what? Changing T, changing G. Okay, intuitively and graphically. So let's talk about what happens algebraically. For example, here, if I increase T by $100, what happens to output? You see? Output falls. But how much output falls? More than 100, less than 100, the same amount as 100, how much? Okay, or remember previous example, we increase G. Suppose G goes up by $100. Output rises. Output rises by how much? More than 100, less than 100, is that right? So let's look at that. A little bit algebra. Okay, so let's do algebra. So this is our GDP from expenditure side. Okay, over GDP from expenditure side. So which is demand side? Consumption, investment, government spending. All right? Okay. And this is definition of marginal propensity to consume. What was marginal propensity to consume? The slope of consumption function. Remember, we talked about that. So if disposable goes up, if disposable income goes up by $1, so consumption goes up by how much? Okay, so if MPC is 0.8, then it means what? Consumption goes up by how much? 80 cents. Is that right? Okay, so we know that. Now, also, differentiate both sides. Differentiate both sides, so you get this. Change in Y can happen because of change in C, change in investment, change in G. Okay? Okay, but you remember, this is only goods market. Be careful. In future, you may get confused because of this. This is only goods market. Okay, let me go back. last week. Okay. You see, when I developed model for goods market, only goods market. For goods market, interest rate is assumed to be fixed. You know that? So that's why investment is fixed. So for goods market, interest rate is coming from outside. In a few minutes, you will see that outside is money market. Okay, that's okay. My point here is here investment is fixed. When you have goods market, investment is fixed. So it means change in investment is zero. Okay, so it means what? Let me go back to my place. There was I. Okay, here, you see? Here, this is zero. And also, let me apply policies separately. Increase in G, no change in tax, or other data, okay? In reality, we change G, T, money supply, all together. But for the sake of making life easier, so we do one policy at a time, separately, okay? Suppose I increase G, but I keep taxes fixed. Agree, everyone? Okay. Now, let me apply the definition. So, if MPC, remember, I just gave you a numerical example. If MPC is 0.8 and disposable income goes up by 100, okay, the question is how much consumption goes up? So it goes up by $80, is that right? So MPC times change in disposable income, okay? So this is in fact application of definition of MPC, or just reorganize it, okay? Keep that in mind. And also, you see, remember what was disposable income? Disposable income was income minus taxes, yeah, you remember that? Differentiate both sides, so change in disposable income could come from change in income minus change in taxes, all right? Okay, but remember, in this scenario, we don't touch taxes, okay? So this would be zero. So change in disposable income is coming only from what? Change in income. Is that right? Because we don't, by assumption, we don't change taxes, okay? So change in disposable income is just change in income. Okay, now combine all these, so here, so plug this here, and then plug this here, and also this one is equal to delta y. Just plug it there. Okay? So you can rewrite this as this using definitions and applying assumptions. Okay, here you have delta y here, you have delta y here, so you can take this to the other side and solve for change in y. Is that right? Okay, you see, this relation or this version, the same thing, okay? This version tells me what? If you increase G by $100, how much income changes, yeah? Okay, and you have seen this before in prerequisite courses, possibly, okay? Why this is important? Because it shows the degree of impact of fiscal policies, okay? So in fact, this term is called G multiplier, G multiplier. So it shows if government increases its spending by $1, how much output goes up, okay? So it goes up by this much. It goes up by this much. But don't forget that MPC is between 0 and 1. You remember that? if your income goes up by $1, you consume a fraction of that. Is that right? That fraction is between 0 and 1. Okay? So if MPC is less between 0 and 1, then this would be definitely greater than 1. So it means we have a multiplication factor. If government spends $1, output, demand, income, those three things, go up more than $1. For example, here I have given you a number, numerical example. Suppose MPC is 80%. So G multiplier is how much? If MPC is 0.8, so this would be 5. So delta Y is equal to 5 delta G. Every dollar government spending raises income output by $100, 5 times. All right? So can someone explain this to me? Yes.
So why the investment has to?
Oh, your investment is a function of interest rate.
Yeah.
This is goods market. And in goods market, we assume that interest rate is fixed.
Oh.
Okay, you know that? But again, be careful. In future, when we have full model, investment is not fixed because interest rate is changing. Okay, here we have goods market alone. It's not connected to anything else. But when after this, I develop money market and I interconnect these two markets, so you have feedback. So this interest rate is determined. That is next part. Okay, where does interest rate come from? Next part. Money market. For goods market, be careful. Output is produced by goods market, but interest rate given for any given interest rate.
What about tax?
Sorry?
What about tax?
Oh, tax next one. Next slide. I am going to talk about that. Now, my question. If the government demand goes up by $1, why total demand goes up by 5 times more, by $5? Where does this extra demand come from? So suppose government spends $1 extra. Suppose a government agent goes to a grocery store and buys 1 pen, $1. Is that right? So but how come total demand, planned expenditure, total output, total income, remember all three in equilibrium go up by $5. This extra $4 come from where? You see, intuition. I myself, when I was a student, because I came from non-economic background to economics, I was doing this stuff very well, but I had no idea, no intuition. So it's very important you develop your intuition, yes.
In the banking system, money creation process.
No, be careful. This is goods market alone. No money involved. Can you see that? So money would be what? Next part. Okay. So half of chapter goods market, half of chapter money market. No money here. That's why interest rate is fixed, because there is no money involved. Interest rate, as you will see, second part of this chapter, comes from money market. So that will be next. Here everything is goods. Supply and demand for real output, real goods. So suppose, let me go back to my example. Government agent buys 1 pen in grocery store. So demand goes up by $1. So supply should go up by $1. Income has to go up by $1. How come it goes up by $5? This multiplication factors, these multiplication factors are everywhere in economics. So possibly he was referring to money multiplier. You know that? These multipliers are all over the place in economics. Okay, you have to just remember where they come from. Okay, so your money multiplier. Now we have G multiplier, or as he asked, next slide we are going to talk about T multiplier. Okay, because when T goes up. So, but the question here is, where does this G multiplier come from? Money multiplier, let me refresh your memory. Money multiplier came from the fact that, you remember, if somebody deposited $1,000, banks kept reserves and loan it out again. Loan it out again. That loaning process forever.
But you will sell the same to other people.
It gives you money. Okay, how about this one?
You will sell the same to other people.
No, suppose government buys the pen and uses the pen. I throw it to the garbage. You see here, that's the trick. This is the one that you need to know. You see, government buys one extra pen, $1. Okay, government agent pays $1 to that grocery owner. So look at that. Government spending would be the grocery owner income. So grocery owner income goes up by $1. But you remember, MPC is 80%. So it means grocery owner consumption goes up by 80 cents. You see, that is what? Another demand. So grocery store owner takes this $1, goes to what? A restaurant. Is that right? Lunch, for example. But not one whole dollar. How much? 80 cents. But don't forget that the grocery store owner, expenditure would be restaurant owner income. And that person is going to spend that again, but not 80 cents. 80 cents times 80%, so it would be what? So let me write that. First $1, then grocery store demand goes up 80 cents, and then when grocery owner income goes up by 80 cents, they go to restaurant and spend 80% of that, 64%. But spend that where? I don't know, somewhere else, okay? So it goes on and on and on forever. So total demand goes up by how much? The sum of all these. How can I find this sum? Remember I told you, just remember one relation forever in your life, because in economics you continuously get that. There's a geometry sequence. Okay, geometry sequence. So look at that. What is this total? This total is, remember, I told you remember this. So first term, 1 minus, yeah, exactly. But how much is that?
Next one.
0.8, which is 5. By the way, did you see that here? This geometric sequence formula turns out to be G multiplier. Is that right? So this shows up all the time, everywhere. Okay. And they define that for everything in economics. Okay. Let's go back to his question. What happens if government increases tax? But you remember we do one policy at a time. Suppose we keep G fixed and we increase taxes. Okay? Okay, so look at here. So again, because in goods market alone, investment is fixed because interest rate is fixed. Okay, so change in investment is fixed. change in investment is 0, change in government spending is 0. You remember, we don't touch G anymore. Okay, so delta Y is equal to delta C. Okay, and this is C. Okay, consumption as a function of disposable income. Okay, but be careful. Now, disposable income is changing by two things: income and change in taxes. Okay, so let me. This is a definition of marginal capacity consumed, and look at this one. Change in disposable income is change in income minus change in taxes. Okay, so plug this here. Plug this here. So imagine this. Is that right? So, and this is just MPC. So MPC times that. But you have delta Y here, you have delta Y here, you have to take the second one to the left, factor out, so it would be something like this. T multiplier, this is T multiplier. It shows impact of $1 extra taxes on output. Okay? For example, let me choose the same MPC 80%. So output turns out to be -4 delta T. So T multiplier is -4. Okay. So did you see that? So it means what? It means if government applies so $20 tax cut, so output goes down by $80. So let me compare these two. So G multiplier, T multiplier. So this was 5 and this was -4. See, compare G multiplier and T multiplier. 5 versus -4. First of all, this is negative. This is positive. Let me put a positive sign here. Is that right? Okay. What does that mean? Sign means direction of impact. G multiplier is positive, so it means if you increase G, output rises. But of course, we showed that if tax goes up, output falls. Okay, that's a sign. That is the sign. Now, forget about the sign, just focus on the size. Sign is representing direction of impact. Now look at the size of impact, 5 versus 4. Why impact of tax is smaller than impact of G, government spending? Suppose government increases G by $1 or increases tax by $1. Why impact by G is larger than impact by T? Yeah? Exactly. You see here, because G is affecting output directly. You remember what was C plus I plus G? Is that right? You see? Impact of G on output is direct, but impact of taxes go through consumption. Is that right? And when it goes through consumption, as he said, any impact is multiplied by MPC. Is that right? So if government increases my taxes by $1, okay, I reduce my consumption not by $1. I reduce my consumption by 80 cents, less than that. So in fact, look at that. From formula point of view, T multiplier is G multiplier times NBC. That's obvious. So, or we can look at it this way. So 5, how do we get 4 out of 5? 5 times 0.8 NBC. Yeah, exactly. Okay. So this is very essential to understand that multiplier comes from the fact that each person's expenditure is another person's income. Can you see that? So it goes to infinite spillover happens. Number one. Number two, which is very important, impact of G is direct. Impact of tax is indirect, going through consumption. Now, this becomes very important if you take CO6. Okay, so in CO6 they talk about a consumption function, and you can show that under some circumstances. So whenever I teach CO6, it takes me two weeks. Okay, MPC may converge to 0. So it means what? So it means if you give people a tax cut, so here we said what? If give people a tax cut, disposable income goes up, consumption goes up. But that is not true if MPC is small. Can you see that? So every tax cut is multiplied by MPC. But in CO6, they talk about scenarios that this may be very close to 0. Okay. So it means tax policies may not work because they have to go through consumption, and you are not sure how consumers react. Okay, so this is Keynesian view. In Keynesian view, you apply the policy, you get the result. Okay, but in CO6, they put a question mark on this. Okay, they talk about expectations, more advanced theories, talk about 2 Nobel Prize winning consumption theories, and over there, when you give people a tax cut, they may not increase their consumption, they may increase their saving. They may save it. Okay, so it means impact, this impact would be closer to 0. Okay, so, but again, you have to wait for CO6 if you take that course. Okay, let's do another exercise that turns out to be very crucial for us, for the future of this course. Okay, what is that? You remember I told you, for goods market, interest rate is exogenous, coming from outside. Be careful. Real interest rate for the economy is not fixed. It's not exogenous. It would be determined by second part of the course, okay? I repeat, this is so important. Some students get confused. This is only goods market, not connected to anything else, okay? So we are going to gradually consider those other factors, okay? So in fact, there will be feedback, okay? That feedback goes through real interest rate. Okay, you see, suppose interest rate is fixed, okay? So you know that this is your investment, fixed, is that right? This is your planned expenditure, yeah. And here you have equilibrium, yeah, short term. Now, imagine I said interest rate is coming from outside, inside. Suppose interest rate goes down. What happens to goods market? You ever plot a graph? Anyone? if interest rate goes down. From graphical point of view, what do I have?
Demand goes up.
Sorry?
Demand goes up.
Yes, but before that, why demand goes up?
Cost of borrowing goes down.
Sorry?
Cost of borrowing goes down.
Yes, and when cost of borrowing goes down, what happens?
Investment.
Investment, right? Remember, for that intuitive part, please don't miss any step, okay? Yeah, I mean, you see? So from graphical point of view, this shifts on. And then what we get, what he said. So demand curve, planned expenditure, so-called demand, shifts up, and then short-run equilibrium rises. Short-run
When
equilibrium.
we say investment is fixed, we're still allowed to move it up and down. It just means fixed.
No, investment is fixed if interest rate is fixed.
Yeah.
Yeah, but here my question is, what happens if interest rate changes?
Then it's not fixed anymore.
Yeah, I mean, so it's not fixed, it's what we call it, is exogenous. It's coming from outside. In fact, as I said, the second part of this chapter is about where is this outside? We are going to determine that. Okay, that's why I am repeating so many times that this is goods market alone. Okay, but when we develop other markets, we connect them, we are going to have continuous feedback. So then interest rate is endogenous for the economy. Okay, but I really go towards that very slowly. I don't want to jog a lot. Okay? I take my steps very slowly. Okay? So, okay, guys, do I agree with this? So, if interest rate, if somebody gives me this news that interest rate is lower, as you guys mentioned, cost of borrowing goes down, that means investors invest more. So, from my graph point of view, that would be a shift, upward shift. But remember, planned expenditure is, we did this last week, vertical addition of CIG. Is that right? So that means planned expenditure shifts up. When planned expenditure shifts up, we go to a higher short-run equilibrium. From intuition point of view, this is part A. Part B, step by step, lower the real interest rate, investment rises, as you guys mentioned. So planned expenditure rises because investment is part of planned expenditure. So excess demand for goods. So excess can add excess demand for goods. Okay, so write it here. For goods. But what happens when there is excess demand? Firms have to sell out of their inventories. Because remember, again, I repeat this stuff, is cemented in your head. Is that right? Because this is short run, price is fixed, and firms sell as much as they can at this fixed prices. Okay? And here, because there is excess demand, they have to sell out of their inventories, and inventory levels stop falling. Is that right? And firms realize that so-called demand is strong. So what they do? Output rises. Then output rises, income rises, disposable income rises, so consumption rises. Okay? Yes.
In the event, do we start before investment or do we start from investment?
For this, because when interest rate rises, there is nothing in between. Or maybe you explain that cost of borrowing. Yeah, as a good measure, you can write that too. Doesn't hurt. Yes?
So we're saying consumption rises at the end of that, push the planned expenditure further.
So it means this one,
Yeah.
consumption,
will it push the planned expenditure line further up?
Okay, that question is a $1 million question that generally I don't explain unless somebody asks that, okay? Okay, because it needs extra explanation, which is good, but generally, if I explain that without question, I make possibly the rest of class more confused. You see, that $1 million question is this. Consumption rises. Do we have extra shift in aggregate, in planned expenditure? Anyone? Yes?
Yes, it's similar to government purchase multiplier.
No, it's not similar to that, as a matter of fact. So, yes?
I mean, just algebraically, you would think yes, because planned expenditure has C in it, so changing C means it would go up.
Okay. So, actually, see, there are two scenarios. Sometimes you have extra shift, of course not here, but in future when we have more complications. So, generally we assume that that shift is including the ultimate change, okay? However, be careful, not here. That's why, in general, I don't explain this unless somebody asks for that. You see, guys? Okay, I need space. Okay, you see, this is always true in economics, but specifically in macroeconomics. We have two kinds of changes in variables. Number one, shifting the whole curve. Number two, moving along a curve, okay? So if you ask me, this is the most confusing part of macroeconomics. When a change is causing a shift, when a change is causing move along, okay? So generally, you see, when you draw, I don't know, I mean, y versus x, okay? Any value, okay? But here, that's why I ask you always look at what we write on the top. You see? Given what? For example, given z, w, I don't care. Okay? And suppose the curve is like this, or whatever you want to match. Is that right? Okay. You see, guys? Given z and w, relationship between y and x is like that. Is that right? So if z changes, if w changes, you would have what? You would have a shift. For example, suppose z goes up or w goes up or both, I don't care. So what happens is, for example, you have a shift. Can you see that? Because the reason behind that is this curve that I drew is for a given z and w. Yeah? So it means I kept these two fixed. I drew y versus x. Can you see that? This is called shifting the whole curve if your given variables are changing. So that's why those given variables in macroeconomics, they are called shifters. They shift the whole schedule. They have the whole curve. Okay? Okay? That's one plan. That is one plan. Okay, this is if z goes up, w goes up, for example, the whole curve shifts up. However, imagine this scenario. Suppose z is fixed, w is fixed. Now x goes up. What happens now? See? If given variables are fixed and only x goes up, y goes up, but along the curve. Can you see that? So, variables which are here variables which are here, they never cause shift. They cause move along. Is that right? This is super important, okay? In fact, if you ask me, the most confusing thing in macroeconomics is what? Because when things become messy, graphs become complicated, shifts versus move along becomes a little bit difficult to recognize. But that is the test. Should I shift or I should just move along? So the test is very easy. You see, if your change is involved with variable on horizontal axis, variable along vertical axis, you have always move along. Okay? However, if given variables change, then you have what? Shift. Okay? So now let me go back here. Let me go back to very original graph here. Okay, you remember this one? Did you see that top? G, T, R are shifters. Anything else is not a shifter, cause move along. Do you see that? That's why, again, if she hadn't asked me, okay, I wouldn't explain that. Because again, some of you may get more confused. So over the course of past 30 years, I realized that more explanation sometimes makes the situation worse, okay? But she asked it, she saw that. Okay, there are very few people who are seeing it. Okay, so you see, we changed G, we shifted. You remember that? We changed T, we shifted. We changed interest rate, we shifted. Okay, but look at here, consumption. Consumption is what? Disposable income. So if income goes up, consumption goes up along the curve because Y is here. Is that right? But if you tell me that no, we have tax cut, oh, that's a shifter. Okay, then I'm with you. Did you see that? So in this case, so here, this increase in consumption is because of increase in, look at that, increase in income. Increase in income, output, is not a shifter. So the test is easy. Any variable along horizontal axis, any variable along vertical axis, they never shift, they cause movement. Any other given variables, they cause a shift. Is it clear? Okay, so if you get this, macro would be very easy for you. Okay. Now, guys, this exercise is so important. Why is it so important? Because I realized something very important. We realized that equilibrium in goods market is not unique. It's depending on interest rate. If interest rate changes, equilibrium would change. So given that real interest rate can be anything, so equilibrium in goods market can be anything. So I have infinite numbers of equilibrium points in goods market. Okay, but my next question here is, where are they? I am going to find all possible equilibrium points in goods market. How can I do that? Just based on this exercise. Remember, I change interest rate and I find them one by one. And I connect all these equilibrium points. And that is exactly my job next step. Okay, so let me get rid of this. Okay, so this is planned expenditure. Oh, sorry, this is supply curve. Remember that? For famous 45 degree line. Okay. But what is demand? Demand for goods. This is supply of goods. Demand for goods. I cannot draw demand for goods. Why? Because I need what? I need interest rate. I need interest rate. Okay. So because I need interest rate, let me choose an interest rate randomly. Let me choose this. I don't care. Whatever you want. Okay. That is interest rate. So if that is interest rate, cost of borrowing is R1. So I1, is that right? Guys, please focus here, because if you don't get this, you are not going to get the rest. Okay? So this is investment. So C, you know that, offer sloping, G, fixed number. So I can draw planned expenditure, and that would be my equilibrium in goods market. But don't forget that equilibrium in goods market Y1 is corresponding to R1. Okay? So it means what? By the way, did you notice that I have created a new coordination? So R versus Y. It's a new thing that I am introducing, and this turns out to be one of the most important terms in this course. Okay, so it means this equilibrium output is corresponding to just that interest rate. So in this space, R versus Y, that would be 1 point. 1 point. Okay, but remember I chose R1 randomly. Let me choose another one. Okay, suppose I choose this one. It's up to you. You know, whatever you want. Whatever you want. You see, I reduced interest rate. Agree? Okay. What happens? You remember previous slide? I just did this exercise. Let me show you. Remember this exercise? We did this exercise just for now. Okay. So investment rises, planned expenditure rises. So output rises. We know why. Previous slide. Okay, so that gives me another equilibrium in this structure. Is that right? Okay, guys, please go home and repeat this 10 times. Okay, just choose different interest rates. So choose different interest rates and find the equilibrium points. But because we don't have time here, possibly 2 would be kind of enough. So I connect these points and we call it IS curve. What is IS curve? IS curve, remember my plan? IS curve is the geometric location of all possible equilibrium points in good market. See, let me write it here nicely. So, IS curve is the geometric location of all combinations of R and Y that bring the goods market to equilibrium. You see that? So any point outside IS curve is not representing an equilibrium point in the goods market. Okay? Do you agree with this, guys? Yes? This is so important. We are going to have questions for final exam about this. Okay? Can I be more specific about that? Okay? Very clear. That's for sure. Yes?
This is with the assumption that the government spending is constant.
Yeah, you meant all those given things are given. Yeah, yeah. So 2 things, because we need to use it in a few minutes. Number 1, IS is representing all possible combinations of R and Y that bring goods market to equilibrium. Number 2, have I constructed IS Remember, I chose a bunch of interest rates. Remember, you were supposed to go home and make it 10, okay? So, well, 2 would be enough for me, okay? So, I constructed this. So, 10 different interest rates, 10 different points. Yeah, I just connected them. Why I am telling you this? Because in a few minutes we need to do that, and you are going to ask me for sure why you are doing this, why you are doing that, okay? So remember, this is how we constructed that. By the way, we do this graphically as usual, algebraically and intuitively. That is graphical version of derivation of IS curve. Derivation of IS curve. In your exercises, you need to find IS curve algebraically. For sure, 100% you have a question like that in final exam. Can I be more? So, have you seen anybody tell you final exam question like now? 100% you have a question, algebraic question about this. So I am going to ask you what? So I am going to ask you, so I give you what? I give you government spending, investment function, consumption function, and question number 1 would be find IS curve. So algebra, remember that? Okay, how do we find algebraic derivation of IS curve? Okay, very easy. First we write down planned expenditure curve, which would be C plus I plus G. Okay, I will write that down. And also supply of goods. So planned expenditure is equal to Y. And then IS is representing what? Equilibrium in goods market. Equilibrium in goods market means what? Intersection of 45-degree line and planned expenditure. So it means these two are equal. So this is algebraic version of IS curve. Be careful. The only difference between IS curve and planned expenditure curve is left-hand side variable. So IS curve, because it's representing equilibrium, left-hand side is output. But planned expenditure is representing everything, not necessarily equilibrium. So that would be planned expenditure, right? Algebraic version. So in your exercises, tutorial questions, you are going to just do that.
Is it possible for consumption to be a function of interest rate as well?
That is a good question that you remember we did that before, and I put it in your. As you will see in your exercises, yes, we do that, okay? But it causes too much calculation problems. Therefore, I generally don't ask that in. But yeah, in exercise. But it causes so much calculations, extra calculations. Yes.
So, in an exam, can you just get like 2 points? Or we need to calculate more?
No, two should be good.
Oh.
Yeah, yes. But I tell you why 2 more for a few, because in few minutes we need that.
Oh.
That's why I emphasis on that. Okay, guys, we do everything in 3 ways. We did graphical version, and he asked, for example, what could be the possibilities. This is algebraic version. So I am not going further because you have functions, you have to do subtractions, additions, solving, and it's in your tutorial question. Okay. Number 3 is intuitive derivation of aggregate supply curve. What does that mean? Intuitive derivation. So you can ask this question: why IS curve is downward sloping? Remember that? I showed you. You see here. You see here. For each interest rate, so output would be okay. So So intuitively, how does the relationship between interest rate and output look like? So, or how can you prove a S-curve is downward sloping? Relationship between output and interest rate. By the way, did you see that? We made interest rate variable. Now, can you see that here? Okay, so anyone? So, how do we know S-curve is downward sloping?
Can you say that if interest rate is reducing, investment will increase as consumption constant and environment?
Yeah, exactly. Especially, I like her explanation because she started from right place. You started by changing in interest rate. Is that right? Because believe me, how many times I get that question in the exam test or something, and people fail to explain because they started from wrong direction, from wrong because of starting wrong point. So exactly as she said. Did you hear what she said? She said, suppose interest rate rises or falls, it doesn't matter. But the point here is, you should start from interest rate. Why? You remember the beginning of this part. For goods market, interest rate is given, is coming from outside. For goods market, interest rate is exogenous, income is the outcome. Okay, so you have to start from this. Okay, because in a few minutes we will see in other market that we are going to discuss, everything would be upside down. Okay, so okay, exactly what she said. Suppose interest rate goes down or up, doesn't matter. Okay, so interest rate goes down, investment goes up, in higher plant expenditure, excess demand for goods. Okay, inventory level. By the way, this is not new. I just formalized them. Okay, inventory levels fall, and then firms increase their output. See, did you see that? Interest rate goes down, output goes up. Negative relation. So in goods market, relationship between interest rate and output is just negative, because in the next market that we are going to start, relationship would be positive. Would be positive, yes.
So in an exam, you answer like that?
Sorry?
So in an exam, you answer like this?
Yeah. If I ask you to write down the intuitively explain the shape of the S-curve, it's just that. In fact, sometimes you make business based on one of my past student experience, and we went for a job interview. And he said, they asked me, in a given economy, relationship between real interest rate and output is positive or negative. So it depends on which market we're talking about. In goods market, relationship is negative by S-curve. By S-curve is dictating relationship between interest rate and output in goods market. Now, the same relationship in next market, money market, is positive. So the answer is, okay, that curve has another name, LN curve, okay? So it depends on which market we're talking about, okay? So goods market, oh, as a matter of fact, here you go, actually it's time. So that's the end of IS curve. So guys, in future, in any complicated situation, whenever we talk about goods market, it is represented by IS curve. Is that right? So this is short run. Okay, let's go to the next market, so-called money market or asset market. Actually, let's do this. Let's take the break now, okay? And then when you come back, we start this right from the beginning, all of that. So please come back, please.